the way we are going?
Yes, sir.
Okay, no problem. No problem. This lecture will be, I will give the supplement, like the additional text you need, I will supply it, no problem. Because we are now trying to, for example, you are an system engineer, okay, as in an optical fiber communication, like fiber at home or this kind of company. So you're designing that, okay, how my system will work. That's designing we are doing actually. What are the ways to transmit a optical system. Today we will actually finish by optical transmission, okay? Then tomorrow or next time we will actually discuss about optical generation. In the generation we will discuss more about equation. Once you understand generation, transmission is okay, because transmission is also another kind of generation, because without generation you cannot transmit. Whatever happens in the transmission also happens in the generation, no problem. They're almost like synonymous names. Like if you go to through few lectures, then you this will be easy for you, no problem. And also, whenever I will declare the exam, probably if you want, I will do a review class, no problem. Okay.
Okay, sir.
Okay, no problem. Okay, see, this is one example of transmission. You see, there are another example where you have a data signal. This data signal is varying. Data signal is varying, and means actually laser light is also varying. And the same light you are going through optical fiber, and the photodetector means photodetector signal is also varying, right? Because if fixed current is varying, light will also vary, isn't it? Because laser receive a constant current, so that it gives you constant light. If you vary the current, the light will vary. That's fundamental. We have seen it in our laser mechanism. So optical photodetector current will also do. Here you see whatever we did it here. Data signal will is modulated by the carrier signal. Now they are different. They are separated. So the carrier signal, same thing. The carrier goes and the photodetector, and they are actually mixed here. Whatever mixed here, you see at the beginning of the signal before transmission, we are actually doing it separately. Doing it separately. Same thing, same output will get, isn't it? Because you see the data signal and the reference signal, they're modulated. That is actually our like demodulated signal. But what is the disadvantage here? You have to use two separate link, isn't it? This is the
Yes,
diode,
sir.
optical, and photodetector. This is on one setup. There is another setup. So this setup is expensive, right? Because you have to repeat the setup. But in a sense that this is actually a very robust system. Like if you need a very robust transmission system, then you will actually make it separate. So separation of signals significantly increase the dynamic range. What is dynamic range? Remember, dynamic range is nothing but the ratio between the largest and the smallest value on a certain means is for example, if you think of an image, then dynamic range means what? For example, you are zoomed in, zoomed in, zoomed in. If you have a high dynamic range of a picture, what does it mean? Means actually you can zoom in very very high number, 10 times zoomed in. Still, your signal picture will be very clear, isn't it? Because it's dynamic range. Small quantity is very very like the you have very smallest quantity and the largest quantity both. The range, that range is very high. Those who do photography understand this one, that if I have dynamic range, high means actually anytime I can zoomed in from this digital picture. That's it's actually saying. Okay, what are the other ways? Okay, same thing. This is actually the same mechanism, only let's see. Mm, okay, here this multiplexing happens in the photodetector. Photodetector is nothing but a multiplexer. Okay, in whatever we do multiplexer in RF domain, photodetector do the same. What does the photodetector do? We know in photodetector, for example, we have seen it in a photodetector. What happens? There light must fall, isn't it? In the photodetector, that is this connection. Light must fall on the photodetector, and in the same time, photodetector must be, for example, if we say PN photodetector, then this has to be biased, reverse biased, isn't it? So this biasing, this is a DC biasing. That one actually do what? That one is actually this one, the biasing. You are giving a DC current so that your this photodetector is biased. The output of photodetector also a DC, and photodetector also need a DC to be keep biasing. So you see, this photodetector is influencing this photodetector, which is actually a mixture, nothing but the mixture. This is happening here. Okay. Okay. I'm looking. Okay. This one is quite interesting, and this is probably the most famously used in modulation system. You see, you have a laser giving a constant current. You passed it through the Mach-Zehnder modulator, for example, Mach-Zehnder modulator, and this is the RF signal. And this RF signal is coming from the same thing. You have a signal data, you modulate by the carrier LO, so you have a RF signal. Based on this RF, for example, you remember what was the mechanism of the Mach-Zehnder modulator? Which material we used in the Mach-Zehnder modulator? Remember, in the modulator, I gave it in the last lecture. Forget, huh? Lithium niobate, which is a voltage sensitive. The refractive index of lithium niobate changes by the voltage. So RF is nothing but the voltage, which fluctuating the voltage, which will ultimately fluctuate the current. That mechanism actually detail discussed in our modulator. So it goes through fiber, means actually there's RF, the optical signal here is actually modulated. This was a fixed of optical, this was a DC like DC type of optical signal. Now this is a modulated signal. This optical signal is modulated same as the shape of the RF. The way this is fluctuating, the same way the optics is fluctuating. So it can go through fiber for a detector and output. You see, you are inserting information. Which one is the information here? You are transmitting what? RF signal. Which one is RF signal? This is RF. You are transmitting RF signal through the optical fiber. The same thing happening again and again. You see, you are transmitting an RF signal through an optical fiber. You are transmitting an RF signal through an optical fiber. That's the same thing happening again and again. Got it? So this is we call transmission of millimeter wave signal. Means actually some RF signal is inserted in this millimeter wave signal. Same thing, this mechanism can be divided same as the previous example. So I'm not going through this one. So I'm giving actually giving you the idea. And for whether it's optical generation or transmission, these things happens. Optical heterodyne technique. Whether it's a transmission or generation, this mechanism always happens there. Okay. So this is going to the tricky little bit, like equation. Okay. Should I stop here? Tajdid, you joined, right? Hello, guys.
Yes, sir. I think we can stop here.
Okay. So because it's going to little bit tricky, so I will stop here. I'll stop the recording.